Perseverance is an apt name for the latest rover to visit Mars. Only around 40% of missions are successful, and this statistic shows that it's far from straightforward to send a probe to the red planet. However, NASA's Mars 2020 mission, which features not only the Perseverance rover, but also a helicopter drone named Ingenuity, landed successfully on February 18, 2021. The mission has technically been in operation since July 2020, but the landing marked a significant milestone, as it represents the most technologically sophisticated equipment that humanity has ever sent to our closest neighbour. To be able to navigate the harsh planet successfully throughout its planned Martian year on the surface, or 687 Earth days, the rover has had to be engineered specifically to carry out its important operation. In this video, we're going to look at this engineering in more detail to help us understand the preparation that went into developing the technology that may pave the way for an understanding into Mars's past and our future. The mission has 4 key objectives. 1. Find areas of the planet that could have been habitable for life. 2. Try and find evidence of this life. 3. Collect soil samples that may potentially be picked up on a future mission. And finally 4. Test oxygen production from the atmosphere of Mars in an effort to see if humans could sustain themselves on the planet. To summarise these objectives, the Perseverance rover is looking for life, the habitats for life, soil samples, and to assess if we could live there. This is why the mission is so important. It could pave the way for humans to visit and stay on Mars, a target that many scientists have agreed is something we should aim towards to increase our chances of survival long into the future. But how is the rover designed to carry out these tasks? One of the major improvements on its predecessors is the AI within the rover. Perseverance is self-learning, just like an autonomous vehicle. The advantage of this is that it can cover more ground than if it were manually moved. The more ground that's covered, the more we know for future missions. The rover's machine learning algorithms and sensors help to navigate difficult terrains by itself and collect the data as it goes. It's also very cautious in an attempt to preserve itself. Its designers have created a 2.5 meter radius around the rover where there can be no hazards, or a 5 meter diameter safe zone. For example, if the rover sees 2 rocks that it sees as a threat, it will only go between them if it has much more space than needed. All the while, its algorithms are being developed and Perseverance learns more as it goes. A cautious approach increases its chances of operating for longer and therefore picking up more information and essentially getting smarter. One of the key pieces of data Perseverance has been designed to collect is potential for life within soil samples, and the rover has another trick up its sleeve to be able to do this efficiently. In an effort to find microbial life, it uses laser technology. It can fire a laser to study very small rock targets from feet away. This technology can provide lots of information including imaging, chemical composition analysis, and mineralogy. A massive advantage of this laser is that it can cover all the hard-to-reach places that its arm can't reach. Another nice extra feature of this advanced laser is that it also clears dust to give the rover's sensor a clear view of what it's looking at. Another improvement on past rovers is its wheels. This has been a key issue on the Curiosity rover, its main predecessor, on which the current rover was based. A huge amount of testing went into choosing the right wheel to use. 20 different designs with different treads were used. A year later, and the winner was finally chosen. It had 48 gently curved grouses to replace Curiosity's 24 chevron counterpart. They now make up the 6 wheels on the current rover, measuring 52.5 centimeters in diameter. Although Curiosity has far outlived its original shelf life of 2 years, to the point where it's still roaming the planet today, the hope is that broken wheels won't be a source of any problems for Perseverance on its epic mission. Currently, Perseverance is carrying an interesting part of the Mars 2020 mission attached to its undercarriage. This is Ingenuity, which, if all goes well, will complete the first powered flight on another planet. The robotic helicopter will be deployed from the rover's deck in very short flights of about 90 seconds at heights of 3 to 5 meters to test its capacity to fly through the extremely thin atmosphere of Mars, an atmosphere 99% less dense than Earth. Not to mention the extreme cold that it will have to endure, of temperatures of up to -90 degrees centigrade. These challenges have been tested in similar environments on Earth, but the harsh climate on Mars itself will test Ingenuity's engineering to its limits. Assuming it withstands these conditions, the drone will communicate back to Perseverance with state-of-the-art autonomous technology. This mission that is happening during a live stream culture back here on Earth will reflect this culture. More than ever, people will be able to follow a mission's progress live using the rover's 23 cameras. These cameras have other uses on top of streaming. They are the robot's eyes and other senses as it navigates the rocky planet. 7 of these cameras have already assisted in the landing and descent of Perseverance, and on top of these are 9 engineering cameras that help navigate as well as look for hazards. The remaining 7 cameras are known as science cameras, which can analyse materials and features the laser that we covered earlier. 2 of these cameras are known as Sherlock and Watson, which exist on the rover's impressive robotic arm. The arm itself is similar to a human arm in that it can use a variety of tools to extract whatever samples it needs to. This arm includes a sensor to protect the robot from contacting the surface in error, and this reduces the chance of damage. The arm also has a drill, which will use rotary motion with percussion if needed to get into the Martian surface and collect samples. There are 3 different attachments that Perseverance can swap out in order to get the samples it needs, depending on the challenges it faces. Another key part of Perseverance is its unit that will be testing the possibility of converting Mars's abundant CO2 into breathable oxygen. This is known as MOXIE, or the Mars Oxygen In Situ Resource Utilization Experiment. If it's successful, not only would this be one giant leap in terms of sustaining life on a new planet, but it's thought that the technology used for MOXIE could one day be used to produce rocket fuel by future astronauts, as they make future journeys to Mars. This could potentially be key in missions to and from our potential new home. MOXIE is a test unit and about the same size as a car battery. If we wanted to develop this technology for a mission to develop fuel, we'd need a unit about 100 times bigger than this. But if proven to work, this small unit might well unlock a massive piece of the puzzle for travel to and from Mars. So there you have it, the insane engineering of the Perseverance rover. The robot represents the best technology that we as a species have to offer. And the hope is that it will return crucial data and to help us understand if any life existed in the red planet's past, and if any will, courtesy of humans in the future. What do you think about this mission? Do you think it will help us one day set foot on a new planet? Let us know in the comments, and please like this video if you've enjoyed it. If you want to see more videos out of this world, then subscribe to Space Aspect. Thanks for watching.